The point that we want to say is that there's a lot of smart solutions out there delivering silos of data. They're easy to realize, but don't actually deliver the value. So as we can see, we're linking operational technology to IT technology. That's a common message that we see within the field. What we really want to sort of express is what our resolute desire is to autonomously run the building efficiently. That's the goal of our business. And that means fusing a wider data set together. So here we've got technology. What we need to do is bring together the building space. So we need to bring that data in. We need to understand how the people are interacting, not only with the technology, but also with the space. And we need to understand those assets as well, the process that's going through those assets. So not just what assets are there, but what are they actually doing? So understand the business process. So that's fusing quite complicated data together. And the way that we do that, so we've really got 4 areas of data. We call it the space data or the location information. We've got the elements that are happening with the building, the process elements, the sensory elements, the conditions. We've got the actual physical assets, the things that are in the building, and then we've got the interaction with the people, the way that the people. And how do we do this? Well, we form a twin of what the building is doing, a real-time model of the building. Now, we've had twins in building for a long time. That twin technology exists within a BIM, but it really only takes a building from concept to commissioning, and then it gathers dust. So a twin takes that data and moves it on to be value in operation. And that's where we are working, and we're not working in the same siloed way that we used to work. We're working in partnership with other organizations to develop an open standards-based approach. So we're working with a number of organizations, but the basis of our twin is formed around a different data schema. Traditionally in buildings, we've stuck with SQL models, which are relationship databases, and they're very, very inflexible. We're now moving into what we call knowledge graphs or semantic web databases, which enables us to fuse all of these different types of data together in a very, very flexible, extendable way. So that's really important, because bringing the space data or the location-based data, which is the L in the leap, the events that are happening, which is the business process and the sensory data that's happening, the assets, which are the things within the building, and then the people into one data construct. It's very difficult from an SQL perspective or even a traditional no SQL tagging perspective, such as Haystack, which is another data analytics algorithm. So we need to make something that's very flexible and very extensible to be able to get that real-time twin. Then we need something that can be abstracted. In other words, we've got applications that we need to build on top, and they need to be able to work and be portable across many buildings. And buildings, as we know, are completely unique. The physical dimensions, the location, the equipment that goes in them, the way people use them, even the naming schema of the building, it ends up that the building's completely unique. So we take one application and we move it to another building, and it won't work very well, because all of the naming conventions are wrong. Everything's off. So we then need to re-engineer that application to make it work. We need to abstract, similar to TCP/IP and computing, or USB and sort of connected devices. We need to abstract the building from the data analytics and the applications. And that's where we talk about this common data model. So as I said, we're working in an open way now, completely different to the way that the organization used to work. And we're working with people like IBM, the Department of Energy. Several different organizations are cottoned on to the same idea. And we're working with a number of universities. And we've developed a data schema which is called BRIC. It's an open ontology. It's a naming classification system. And it allows us to use that graph database in a standardized way and abstract our applications. And that means we can apply artificial intelligence. And that's how we get to value. So there's a lot of systems out there that are dashboarding. In actual fact, 90% of the data platforms that we've got out there, all they're doing is dashboarding data and giving you a wonderful graphic about what happened historically. What we need to do is develop applications that can develop predictive models to then optimize the building. And that's how we get to autonomous building running. And we've done it. We've done it in certain ways. We've got model predictive control over systems now running the plant autonomously, set point control autonomously, and we do it more efficiently than the human, or we do it more efficiently than the building management systems can do it and be programmed to do it. And what does that give? Sustainability. It gives predictive maintenance. It provides us with insight to maintain and optimize the platform. So we don't need human interference to run the building. We can actually use AI and machine learning to run the building. So that's how we get to AI and machine learning. What we've done is we've developed an open platform approach as well, and we're working with partners. So far we've got 18 partners, and there are over 350 R&D developers. Don't work for us, they work for other companies like Accenture, like Atos. We've just signed up and released Atos, are looking at environmental ESG goals on top of our platform. But really we need to start, everybody tends to start at the bottom, what have you got, and work up. What we need to do is start at the top, which is applications and outcomes. What are you trying to achieve? Which is things like, generically, we're looking to achieve net zero, sustainability. We've got a sustainability goal. Right now, let's identify the data we require to sort of obtain that goal, rather than start off with the siloed approach, start off with the outcome. And then what we do is we enrich that data through the twin, which is again, open standards based, and this is where the common data model comes in. So having a standard abstraction model enables other application providers to also understand that data and build applications very quickly. We then host this in the cloud. Now, some of this doesn't need to be cloud hosted, but we have cloud hosting, and we build the cloud environment that runs things like device management or security and access control. But we put it in a container so we can lift and shift that cloud from Azure to AWS to Google to Alibaba, whatever the cloud provider is, even taking it into private cloud if they need to. So it's a cloud container that enables us to sort of make it portable. And then finally, we need to connect to the devices. So again, we've developed a bridge that enables us secure connectivity in both directions, and enables us to talk standard protocols. So we've got about 10 standard protocols from BACnet, Modbus, OPA, MQTT, all of the different ones that you'd expect, as well as it's developed on a microservices basis, so a Kubernetes or a Docker container that enables us to spin up new applications within the bridge. So actually we can run AI within the bridge and do autonomous set point control over the plant within this device. That enables us as well at each and every level to share an API. So we've got APIs on every one of these levels that we're working with partners on. So you can go onto our website and request an API membership and say, actually, we've got a development that we want to share with Johnson Controls, and therefore this open community of developers sort of extends our buildings. And this, what we're trying to get away from is silos in our building and make best use of the intelligence that we've got within our community. So we've already got 18 manufacturers there working on that platform. So ending on this, we need to focus on the outcomes, not everybody had a solution. Back for the last 20 years, I've seen solutions for everything. Everybody's talking about solution selling. What we're trying to concentrate on is outcomes, and this is really a journey that we're on as well. It will always be advancing. So we're really in the world of IoT, big data, AI, and machine learning now. Buildings are really there. And to take and gain those sustainability advantages, we've got to change the way that we deliver buildings. We've got to change the way that we operate buildings to be able to run. Because if we look at sustainability is a problem, we look at specifically where we are now, and we know where we need to be, we can't operate buildings in the same way. We need to improve that operational efficiency to gain those energy reductions and carbon reductions. And obviously, occupational savings, they really come from things like predictive maintenance, less truck rolls. Our entire business is transforming Industry 4.0. We want to do less truck rolls. We don't want to go to site to fix a system. We want to use a predictive maintenance. If we do need to go to site, we need to send this engineer to site with the right kit so he fixes it first time and it doesn't fail again. But we need to use analytics on our platform to feed back also into our research and development as well to improve our product development as well. So there's a number of things that we're doing there. In terms of applications that we've built on top of the platform, we already have a mobile application that interacts, and again, there's a quid pro quo benefit of the mobile app, is that it benefits the user as well as benefiting other people in the business. And this is part of what we call data democratization. So it's not just a mobile app for the user, there are benefits to facilities, security, all different users from the mobile app. We have an enterprise management application which really binds together sustainability, occupancy, and air quality to drive those energy costs down, but also increase and improve and have a healthy building environment. Central utility plant is an absolutely brilliant use case of machine learning. We can run the plant more efficiently by using a thing called model predictive control. We've developed it, we're running it. We've got over 50 buildings now around the world where we're running the plant using machine learning, model predictive control, and they run far more efficiently with that against sort of a modern building management system, set point control. We're connecting all of our equipment. We're on a journey, we haven't connected it all yet. Everything that we sell though will have a connected framework around it to improve its operations. So we have connected chillers, connected refrigeration, and it's remote servicing, predictive maintenance, all of those things. And we have also a platform of security technologies as well that look at risk and also standard operational procedures.